Hello out there dear friends, and welcome to this video today. In this video in our YouTube channel, guys, we shall be looking at a very important experiment as far as the physics is concerned, which is that you're provided with the following apparatus. You have a cell, a multimeter, a resistor, and cables. Determine the lost PD and the internal resistance of the cell. So friends, please don't forget to watch the video from start to finish, because at the end of this video you shall be able to walk into that physics practicals and answer this question without ease, even though students will find difficulty answering this question. So friends, please, for a quick reminder, if you're new to this channel, don't forget to hit that subscribe button looking at you guys, because we shall be uploading so many contents in this our channel, both in paper 3. As far as paper 3 finishes, guys, we pick paper 2, paper 1 in all the subjects, guys, so you can't afford to miss. You really can't afford to miss, guys. So just hit that subscribe button so that you get notifications of all the contents we produce here. Thank you very much, guys, and let's dive straight into the video. So friends, let's start, because to get this internal resistance done now, we have to draw 3 circuit diagrams. One in which we are going to measure just the potential difference across the cell, then the other in which we are going to measure the potential difference across the cell when the resistor is present, because they've given us a resistor here, right? Because you know that a resistor is a load, right? It is going to absorb some amount of potential difference, right, such that the potential difference across the battery when the resistor is present will not be the same as the potential difference across the cell when nothing is present. Good. Then now we also need to get the current that will be flowing in the circuit when the resistor is present. So friends, let's start with our diagram. Like I said, we need to bring forth about 3 diagrams here, friends. Specifically, we need 3 diagrams. So this is our cell as we have here. Keep in mind that the equation said that it is a cell, right? So we need just this very long stroke and a short one. Okay, most mistakes that students are going to do is to draw a battery. They are going to mark it wrong. Okay, they're going to mark it wrong. So we need that. Then these are connecting wires. Then friends, as we have here, like I said, we have to measure the potential difference, the EMF of this our cell, right? So we have to measure the EMF. Good. So guys, this is our first circuit we have. This is our first circuit when we are going to measure the value of the EMF. Good. So friends, our next guy now, and we are going to have it the EMF as capital E. Great. Then now our next circuit diagram, guys, we are going to have this. We have our connecting wires of this form. Then we have our battery again. In this case now, guys, we are going to have a resistor. Okay, we are going to have a resistor that is being connected, as you can see here. Good. But the value of this resistor, we don't even need its value. Okay, we don't need the value of this resistor, so we can just allow it because we don't need its value. Then now friends, we know that the voltmeter is always connected in parallel, right, since it has a very high resistance. Good. Then we have it of this form. We have the voltmeter, which still has the symbol V. Good. And we are going to label the value we get there as V. Good. Great. Then now guys, our last diagram we have to draw now is the diagram that is going to compose of just this resistor, the battery, the cell, sorry, and the ammeter in place, because we need to get the current that will be flowing in this circuit when they are both connected. Because in this case now we're able to get the potential difference when the resistor and the cell are connected, right? The next now we want now to get the value of the current that is going to be flowing. Great. So in this case now, guys, let's bring forth our next circuit diagram. So we are going to have our connecting wires like this. Then we have the cell. Great. We have a cell of that form. Then guys, as I told you, we need the resistor. Then we also need an ammeter. And an ammeter, guys, as you all know, it is connected in series, right? It's connected in series with the whole combination because it has a very low resistance. Good. So we have the ammeter in that case, and we're going to have the value of current to be I. Good. So friends, these are the 3 circuit diagrams that we need in this question. If you can look so well, if this question is being asked, they will always give it for at least 3 marks. They always give the diagram for at least 3 marks, which signifies the 3 setups you need. It's not that if they give 2 marks it means you need 2 setups. No friends, just that sometimes you have to be so conscious. Good. So friends, having it like that, let me explain again, guys. Let me explain again. The first diagram is to measure just the value of the potential, just the EMF of this cell. Okay, just the EMF only. We want to measure the EMF. Then now the second diagram, right, is to measure the potential difference of this our cell, or the EMF of this our cell when when the resistor is in place. Keep in mind that the resistor is a load. Okay, it is a load. The EMF or the potential difference across this our cell will not be the same as the potential difference we are going to get here when the resistor was not there. Okay, yes, but rather the potential difference we get from this our cell when this resistor is there, plus the potential difference across the resistor, will now give us what? Will now give us the value of the EMF when nothing is connected. Good. Then the last diagram now is to get the current that is flowing, in this entire circuit. Great. So friends, I hope it's understood. Let's go now to the procedure. So the procedure, guys, will tell them that the setups are shown above. The readings of the three sets up, that is the voltmeter and the ammeter, are red. Good. So friends, the setup is very short and brief, very short, because everything is ready on the diagram that we can see. Okay, everything is there. Like I said, we don't need the value of this resistor. Okay, we don't need it. Our aim is just to get the value of the lost PD and the internal resistance of the cell. Great. So now let's go now to our procedure. So friends, based on the setups I have here with me, I have measured the value of the EMF, and it is 2.86. Like I said, guys, we don't expect the potential difference across this cell with this resistor in place to be the same like this value, right? We expect it to be rather be less. That therefore implies now, guys, I've measured the current across this guy, right? I measured the current that is flowing in this circuit, and this is 1.62 amperes. Then now, guys, the potential difference across this our cell with this resistor in place is what? 1.93. Good. It's 1.93. So friends, now this is all about our observations, what we observe from all our instruments that we measured. These are the observations. Good. Then now, guys, let's move on now to the calculations. Now we should tell them that the lost PD, guys, the lost PD in bracket capital IR, or the PD loss, is given as what? E minus this small v. This, keep in mind that this our capital E is what, guys? Is the EMF across the cell, right? Is the EMF when nothing is being connected. Then now this our V now is what? Is the potential difference across the cell with this resistor connected in place. So friends, like I said that these two guys would never be the same. Just as you can see, it will never be the same, right? That therefore implies, guys, that the lost speed in this case, but we have to define symbols. Friends, don't forget that physics is very important in as far as symbols are concerned. So friends, we need to define our symbols. Like I've written here, they said I've written that where R is the internal resistance of the cell. Everything here has been defined except small r, because you know that I is gotten from the ammeter, right? Then E, that's the capital E is gotten from here. V as well is gotten. Good. Then I've written here the loss PD, comma, we have PD lost. So it has been defined. Everything has been defined now. So in this case, guys, we can now go for now to substitute our values. We have PD loss equal to E minus this V. Our E now is given as what, guys? 2.86, right? Minus V, which is 1.93. So if we do that so well, guys, we are going to have an answer of 0.93 volts. So this is the lost P. This is the lost PD that the equation wanted us to find. Then now the equation is in two parts. The equation wants us to find the internal resistance of the cell as well. So friends, if you look at what I wrote here, right, we saw that R is the internal resistance of the cell, right, and the PD lost is given as what? IR. Good. So we are just going to equate this our IR to the PD loss, right? According to this our step that we said the lost PD, comma, we have capital IR. That is the lost PD is the same like what? The current times the internal resistance. Good. Which is the same like the lost PD. So we're going to say that our now we know that our IR, right, is equal to what? 0.93 volts. So if we make our R the subject and we put in the value of I, because I in this case is in what? Milliamperes, right? We have to convert to amperes by multiplying by 10 raised to the power negative 3. Good. That therefore means that we are now going to have an answer of R, that's the internal resistance, to be the same like what? 574 ohms. Good. So friends, this is the value of the internal resistance of the cell. That's its value. Then friends, now I think this is all about what the question was asking. That's just all. That's all about what the question was asking now. So now let's give our inference. Okay, let's give our inference. Our inference in this case, guys, is simply what we wrote here, that the loss PD is given as what? E minus V, and that the loss PD as well is the same like what? I R, where R is the internal resistance of the cell, I is the current flowing. So we'll simply tell them that the loss PD is given as E minus V, and the guys, that the PD loss is given as what? I R. Good. So these are our inferences. Okay, these are the inferences. Or we can either write this IR and equate to this E minus V. Good. Everything is perfect. So friends, this is how we can answer this question and score all the marks. And you should know that, like I said initially, guys, this is physics. Okay, this is physics. You have to define all your symbols. You don't use symbols anyhow as far as physics is concerned. You have to define any symbols, because symbols can mean something else in some other sections in physics. So friends, I'll quickly take it all over. I said we need 3 diagrams of setup. One is to measure the EMF across the cell when none of these things are connected. This is how we have it, because we have just the voltmeter and the cell. We have it as E. Then now we measure the potential difference across this our EMF when the resistor is present. Then now we measure the current, just when now this guy is no longer present again. We are not going to measure now but the current in milliamperes. So we have it. They will do our calculations. Everything is perfect. So guys, thank you for watching the video, and don't forget to like the video, subscribe to it to get all latest contents about all our channel in all the subjects, guys, because as far as practical finishes, we are going to start paper 2, paper 1, and so on and so forth, guys. So you need to subscribe to have all latest updates. And guys, it took me a lot of time to create this content, so please don't forget to like the video, because it motivates me to keep producing more content. Thank you very much, guys, and